And we're ready for notes for 7B in the Math 4 course. And today we're going to be looking at a couple of things. We're going to be selecting a single attribute and creating an appropriate display to share. And, honestly, we're going to go back through some things about CODAP. And, some things we've mentioned in passing, and I just want to reemphasize some of those things. That decisions and choices that you have with CODAP as far as creating a good graph. And also we're going to look at what makes for a good statistical question and what makes for a bad one. And some of the instructions say give me 2 good questions and 1 bad one, just to make sure we know the difference. Now, instead of going with the screenshots here, I'm actually going to go to live CODAP, and I believe, let's see, I gotta do that. There's the graph, and we were talking about age and years. I'm going to drop that down in here, and that's the graph that we had earlier. Now I'm going to stretch this out a bit, and one of the things that we talked about was the need for cleaning data. This is supposedly a survey about high school students, or at least, school age students, which means that my 49-year-old does not belong here. And so when I click, not only does the dot turn green, but you'll notice that the line back behind here, there's my female that's 49 years old. So when you click on that dot, it brings, when you've got the spreadsheet behind you, it'll bring that up. Now I'm going to go up to the eyeball and say hide this selected case, and it goes away. And I'm also going to do that. There's a 21-year-old that technically does not belong in high school, so we are hiding the selected case. And when I've got all this white space that I don't need, and so I'm going to go up to the 4 arrows, and it's going to spread it back out. Now, one of the other things, I'm going to go ahead and kind of jump the gun because this is like about 3 pictures down the page, but it also talks about what to do here. Here we've got a girl that says she's 16 and a half, which everybody else said they were 15 or 16 or 17 or 18. 16 and a half, they must have been ready for their driver's license or something like that. Anyway, that is something that when you think about it, so if they said they were 16 and a half, does that make them 16 or 17? That's what everybody else did. Well, they're not to 17 yet, which means that they're still 16. So I want to take the 16 and a half and edit that to where that they're still 16. So normally what I can do is I can click on that box. Now, for some reason, right now, CODAP is having emotional problems and I can't click on it, but I have in the past been able to click on that and edit it to where I can type it to say 16. And when it does, what happens with the graph is that that green dot will suddenly populate over here, and it'll be gone, and our data will be cleaned up. So sometimes you are going to need to go through and adjust some of the responses. Presumably you're doing that in the spirit of it. Now, sometimes you just need to exclude things. I'm thinking of one of the graphs that talked about how many hours you watched of TV every week or something like that, and you had all of these numbers all the way up through like 100. And then the very last dot on the right said November 7th. And I'm like, wait a minute. So we're talking about watching 10 hours of TV or 20 or 30 hours, and then November 7th is the last data point? Where did that, and it suddenly occurred to me that when you're dealing with spreadsheets, sometimes spreadsheets will automatically take a fraction like 11 over 7 and convert it into November 7th. And so that had to be, in my mind, that had to be what happened there, which, so if they originally intended to put 11 over 7 there, again, if we're watching how many hours of TV a week, I don't know what 11 over 7 must have been, so I'm going to exclude it from my data because it's an answer that doesn't make sense. And you know, your code app is going to blow a gasket trying to figure out how to average it with everybody else. Um, anyway, all right, let's go back to the notes. So we've talked about that. Now, one of the other things that we can do, let's see, now that was class grade. So I'm going to lose this and I'm going to bring down one and I'm going to do class grade. I'm going to drop that right here. Now, this was something that some of you ran into with the test is that, you know, you got these whole, and it's nothing more than a stack of dots. You can hover and it is different data points all the way up and down here. And you know, that's not really the kind of bar graph that I was at. Now, this does serve as a bar graph, but it gives you no specific information. It doesn't tell you. Now, if I go up here and say count, all it does is give me the count of all of them together. Now, part of the reason is because of the nature of the data. Right now, it's looking at grades 6, 7, and 8, and it's taking it numerically. It's not taking them as categories, it's taking them as numerically. Like I could average together all of these numbers and figure out what was the average grade of all of these kids. And that's something that just doesn't make sense. So when I click on class grade down here, there is a toggle on and off switch that goes back and forth between numerical and categorical. Right now, it's treating it as numerical. Which means that we do have access to things like standard deviation and you know, mean, median, and box plot and that sort of thing. But again, what good is a box plot on a graph like this? You know, why are you on the average person here is an 11th grader? You know, we're talking about categories here. We're not talking about numbers. And so a lot of your numerical stuff just makes no sense. You really are treating this as categories. Now watch what happens. Now we've got stacks of dots. And it makes a little more sense. And now, true, I have lost the ability to do things like, you know, standard deviation and such. But I can at least do count and even do percent. And that gives me both of them. Now, if I hover, right now, if I hover over it, I get individual dots. I could go down here and do fuse dots into bars. And when I hover, I get, you know, a lot of what the count and the percent at the top as relative frequency. So, you know, those are some options that if the graph is not doing what you want to, you know, if you want more than what you're getting there, ask the question, is this numeric and it should be categorical, or is it vice versa? You know, should I treat this as the other way, and will that help me any? So that's what's going on there. Now, and of course, we talked about fusing dots into bars that, you know, give you the bar graph like that. We talked about the 16.5 and how you could go in and edit it in that spot. You know, when you click on that dot, it turns green and it shows you exactly the line that is the culprit. And you should be able to click on that box and edit it. Like I said, Code App is having emotional problems this week. Now, this what was travel time to school. So let's look at that. Travel to school, travel time to school. All right. So I'm going to get me a new graph, and I'm going to do travel time to school, and we'll drop that there. And one thing that I don't think that you know, I would hope that you had noticed that I kept, every time that I get a graph like this, I have a tendency to expand it so that things are not so scrunched up in one corner. I got back a few screenshots that were still scrunched up, and sometimes I wonder if that's what led to wrong answers, because some of y'all made a bad choice. Now, this looks like it might be considered a normal distribution until you consider these guys. Now, watch what happens when we do this, when we make a box plot. There's your box plot, and of course this is skewed way to the right. But watch what happens when we show outliers with the box plot. Now all of these outliers are showing up as little pluses. And so if it was your decision to take out the outliers, then you could drag a box over this whole thing. And all of them are lit up green. And then you can go up here and say hide selected case and spread out the 4 arrows. And now what you're dealing with is the main group of the set without the outliers. So, if you feel like your outliers are affecting too much of what's going on. Now, I'm going to go back and I'm going to show all cases. That's how you get it back to where it was. As a matter of fact, I'm going to go back here and I'm going to undo that. Because, this is a case where it is obviously skew right. Anytime that your whisker is longer on one side than the other side. But I also want you to notice something else that happens. Look at what happens when I look at mean and median. My mean is supposed to be, half the data is to the left and half of it's to the right. And that's at 10. But my mean is over here at 14. Now, how did the mean get all the way over there? These guys out here are partly to blame. They're dragging the average in that direction. And that is actually one of the biggest reasons why we say that something is skewed right, is that these guys were dragging the mean to the right of the median. So, all right, let's see what else we got here. And yes, I noticed that some of you on the test did discover that outliers button and had the little pluses and everything. Looked kind of nice. Now, from this graphic display, we're supposed to create 2 good statistical questions and 1 bad one. Now, you can look at the numbers here. I decided to treat it categorically so we could see the dots and we could, put up the count so that we had a better idea of just how big some of these guys were. Yes, there's the pattern that as you get to the older grades, you have more participation. Now, one thing that when I looked at the numbers, I started noticing that for about the last 4 or 5 grades, the females were more than the males. But about the time you got to the 8th grade and you went under the 6th and 7th grade, there were more males than females. And so perhaps a good question here, let's turn on our pen. A good question is, when does female roster outgrow males? That is something that you would have to collect the data, and then you would have to study to figure out when they were more and when they were less, and begin to figure out where is that dividing line. Another good question might be have to do with the curve of this thing. Now, it is a little more pronounced with the males than it is the females. The females, it sort of drops down, but it kind of levels off here, whereas this one still has a definite down and up curve in the males. So perhaps a good question here would be, well, we're talking about the rate of growth of the male roster. And in class, I gave you all a moment to think about this and think, what have we studied last semester that would give us the kind of answer that we're asking here as far as the male roster is concerned. How could we show the rate of growth, statistically speaking? And the answer is regression. We had done regression equations, the line of best fit. Now, what would make it interesting is to plug the male data into Desmos and then figure out, which one has the best R-squared value. Is this a parabola? Is this an exponential? Is this possibly a logarithm? Is it possible a sinusoid? Is it like a sine wave? So we'll look, and those would be things to look at. Now, a bad question here. Bad question is one of the quickest ways to have a bad question is to do one that has only one answer. Like how many females? Were seniors? Well, chart says 133, and bang, you're done. There was no variety in that answer. You didn't even have the male-female variety. You didn't have variety of different classes. It was all about the females and the seniors. So, usually the two quickest litmus paper tests for a good statistical question is, can I gather data, to answer this question? And, is there variability within the data? And this is where our bad question misses the mark, because there's no variability. It's all females and all seniors. Where's the variation there? It's not. All right, example 3, we're going to pull up a file and do class grade to one axis, and we're going to clean it up, and then we're going to add superpower to the other one, and then we're going to, well, it should say pasted there, and it doesn't. But anyway, we're going to ask and answer 2 good statistical questions and 1 bad one. All right, so we're going to start over. All right, class grade. We'll put that there. And let's see now, did we need, no, we aren't hiding anything. If we're going to do strictly high school, then we're going to have to clean out these guys. Those are not high school, so we're going to hide those cases. And we're going to stretch this back out to just the 4 grades. Now, I love how it's, doing 9, 9.5, 10. Are you in grade 10.5? Well, it's treating it as numeric. Now, a question we need to ask ourselves eventually is, do we want to go categorical or not? Well, the other thing was that we're supposed to bring the superpower thing in there. They had a question on there. What was the child's favorite superpower? And I'm going to have to go over a ways to find the superpower, because it's almost at the very end. There it is. All right, so we'll drag superpower over to the y-axis. And so now we've got a sense there. Now, I'm wondering, we treat it as categorical. Yeah, that's actually a little easier to read. As a matter of fact, it would probably be nice if we would put a count. The problem with percent is that the percent either goes horizontally or vertically, but it only makes sense in one direction. So when we've got a grid like this, I have a tendency to leave percent off. So that's what we're dealing with here. So we need to look at this and figure out what are some good statistical questions. And you know, obviously we can. Well, we've got more seniors than anything else. But usually you want to look at the cross between the two. A bad question would be, what was you know, the least favorite of the superpowers, which it looks like super strength would have been the least favorite. And likewise, asking the most favorite. I'm looking really to freeze time is you know, the highest in each grade. 62 here, 30 here, 16 here. Only in ninth graders did more of them want telepathy, but you know, if you were to add this together, you could ask the question, which superpower was most important to the students? That would be one. So we'll go back here and we'll say, helps if I turn my pen around. Which superpower is most important to students in general? Now, when you make a statement like in general, or you know, you're asking, you know, for the group, you know, as a whole rather than individuals. Let's see, now what would be another good question to come from this? I guess likewise you could ask, well, if you ask which power was the favorite of seniors, which power was the favorite of seniors? That was just simply a case of counting. However, you would also, well, you would have to count the different categories, so there is variability there. So now those would make the two good questions. The bad question would be like, how many seniors or how many juniors wanted to fly? You know, that's a question which, you know, when I look back at the data, there's the junior class, there's flying, the answer is 23. I mean, you count them and that's it. That is a rather deterministic answer. That it really does not take into consideration any of the other categories that you're dealing with. All you want is how many 11th graders that actually fly. You're not comparing it to anything else. And so that's what makes it no longer a statistical question. All right, now that is the end of the notes, and then we'll move on to the worksheet in the next video.